factor trees of other numbers. Now, actually, all right, guys, today we're going to talk about factor trees. So factor trees are a way to take a number and break it down into its simplest form or its simplest pieces. And those simplest pieces are actually going to be prime numbers. So these over here are our prime numbers. So if I take a number like 8, I'm going to break it down into its simplest parts. In other words, I'm going to think about what numbers can break down 8 in terms of multiplying. So 2 times 4 would equal 8, right? Now, if I think about these numbers, 2 is going to be prime. So I'm going to circle it because that's as far as we can go. So our goal is to get our original number, the number 8, and get it down into its prime forms. So as far as we can get it down into prime numbers. Now 4 is not a prime number. If we look at our list over here, 4 is not a prime number. So I'm going to split 4 out into its smaller pieces. So I know 4 is 2 times 2. And from there, we know that 2 is a prime number. So that is the factor tree for 8. Okay, so our goal is to get it down into the prime numbers of that number. And now if we think about this in terms of checking our work, 2 times 2 times 2 equals 8, right? 2 times 2 is 4, 4 times 2 is 8. So these prime numbers at the end multiply together to get back to this number. Okay, so let's think about it may be helpful for us to see our prime set. So let me erase these guys. So we're going to do a bigger number this time. Let's do a number like, let's go with 16. Okay, so 16 would be 2 times 8. 2 times 8, so we know that 2 is a prime number, right? 8 is not. So 8, I could do 2 times 4. I know that 2 is a prime number, excuse me, but 4 is not. So we're going to split 4 out again, and 2 and 2. 2 times 2 is 4. So you can see how that is our factor tree. Now you're saying, what if I didn't want to do 2 times 8 as 16? What if I knew that 4 times 4 equals 16? You're actually going to get the exact same result. 4 would be 2 times 2, right? And those are prime numbers. And this 4 would be 2 times 2, and those are prime numbers. So it actually doesn't matter which of the factor pairs that you choose to start out your factor tree. Excuse me. You're going to end up with the same prime spot. All right, let's try another one. We've done a lot of things with 2's here. And 2's aren't always your answer. And sometimes you have numbers that are not 2, other prime numbers like 3 or 5 or 7, or even a little higher and getting into like 13 and things like that. For the most part, when we're talking about the primes that we are probably going to see the most, it's going to be for the most part these first couple. Probably up to 13. Sometimes you'll get some that are in these 17, 19, those kinds of things. But for the most part, the numbers we're going to be breaking down are going to get you prime numbers that are much smaller. Okay, let's try the number 24. All right, so 24. Now, I know that it's even, so a strategy that you could always do is 2 times something if you have an even number. So in this case, I could do 2 times 12. 2 is a prime number. 12, I can split out into 3 and 4. If we check over here, 3 is a prime number. And I can still reduce 4. Oop, not 4. And get my eraser out. Now, the other thing that sometimes people ask, can I do 4 times 1? technically you could, but it's not going to get you it's not going to reduce it anymore. And it's not going to get it to like those smaller numbers that you're looking for. So really you don't include the times one in these. So in this case, this would be how 24 would break down. Again, just like before, when I said with 16, you can start with any factor pair. So I could start with 6 and 4, because 6 times 4 is 24, right? And then neither of these are prime. So 6 would break down into 2 times 3, and 4 would break down into 2 times 2. Okay, fantastic. So that is our factor tree for 24. And again, you can do it either, oops, wrong one, eraser. You can do it with either one of your factor pairs. They both work. They'll both get you the exact same answer. So you and your neighbor could have different ones, and that's okay. All right. What if we have a number like 13? Is there a way to break this down into a factor tree? There actually is not, because 13 is already prime. So we wouldn't need a factor tree for prime numbers. All right, let's try another one. How about, let's do something like 26. 26 you don't see very often in terms of the answer to a multiplication problem, but it is even. So I could do 2, and then anytime I'm thinking 2, I can think half. So what's half of 26? And that's 13. 2 is prime, and then if we check over here, 13 is also prime. So in this case, it's a really short and small factor tree. All right, one more. Let's do 18. Okay, so for 18, a couple of different ways I could do it. I'm going to do 3 times 6, because there's a couple of different factors for 18. I'm going to do 3 times 6. 3 is prime. 6 is not. 2 times 3 would be a factor pair for 6. So 2 and 3 are both prime, so that's the end of our factor tree. Okay, let's do another version of 18, because we could do 2 times 9, right? 2 is prime, 9 is not. I could do 3 times 3, and then both of these 3's are going to be prime. Okay, so that's a quick introduction to factor trees. So this is what you're just looking to break down the number into its smaller parts, its smaller prime numbers that would end up multiplying together to get that number. Okay, guys, thanks. Bye.